So when we talk about graphing radical functions, definitely we can, describe their transformations compared to the parent function. So in your Schoology page, 10.1 graphing radical functions, um, here is like a quick guide on how to interpret or describe the transformations that are happening to radical functions depending on where you see a constant being added, subtracted, or multiplied. Well, first, let's um, let's talk about the difference between horizontal translation and vertical translation. So if you compare these two affect your graph in the same way. They move the graph um, in different directions depending on the sign of the constant. So for horizontal translation, um, take note that the constant being added or subtracted is also inside the radical symbol together with the variable, right? So horizontal translation is being described by constants that are being added or subtracted under the radical sign, okay? While vertical translation um, is for the constants that are added or subtracted um, outside the radical sign. So this is the square root of x plus 7 minus 1, right? Because these are affecting the y values, right? Now these ones are affecting the x values. That's why it's called horizontal. So the effects are happening along the x-axis. Now, it's also important to note that if it's a horizontal translation and a constant is being subtracted, the effect is to the opposite direction. So you see that that's negative, but it's going to the right. And then this is positive, but it's going to the left. Okay, so you've seen this transformations before when we did quadratic functions, and you see that they do the same thing for radical functions. So for horizontal translations, you go to the opposite direction. But for vertical, you have to follow the sign. So, go. Now, same is true for horizontal stretch or shrink. So, horizontal stretch or shrink is again, these are constants that are being multiplied to the variable inside the radical symbol. And just like what we did here, the effect is quite the opposite. So, for example, if this is the square root of 3 times x, so even if this constant is bigger than 1, you're shrinking it. And since you're shrinking it, the factor of stretch or shrink is the reciprocal. There you go. So the reciprocal of 3 or 3 over 1 is actually 1/3. So the effect here is also opposite. So if you're multiplying it by 1/2, okay, you're stretching it, get the reciprocal of 1/2, so your stretch factor is actually 2. Does that make sense? Um, well, maybe you're wondering why that happens. Well, a quick, you know, um, just to kind of illustrate that very quick, if you have like 3x is equal to 0 and you want to get the x by itself, right, what do? You divide both sides by 3, right? So you can have x is equal to 0. So it's similar to when you're solving for the variable x. So since you're dividing it by 3 here, then you're shrinking the function, right? What about when you're multiplying it by 1/2? So how do you get the x by itself? Well, you have to multiply both sides by 2, right? Okay, to get the x by itself. So that's going to be equal to 0. So the process for solving for x pretty much gives you an idea of how that constant will transform the graph. So if it's half x, then to get the x by itself, you have to multiply it by 2, so you have to stretch the graph by, you know, by its reciprocal. So the reciprocal of 1/2 is 2. But um, for vertical stretch or shrink, again, you have to follow the sign. So, if a constant is being multiplied outside, you stretch the graph by a factor of 4. But if you're multiplying it by a fraction, say 1/5, then you're shrinking it by a factor of 5. So these are affecting the y values because they are outside the radical sign. Last but not the least is reflection. So reflection happens when you're multiplying either the radicand or the whole expression by -1. So if the function is being multiplied by -1, you're reflecting it in the x-axis. But if the radicand is being multiplied by -1, then you're reflecting it in the y-axis. So that's just like a quick guide as to how you guys are going to interpret the transformation for square root functions. So now let's look at some examples. Okay. So for the first one, g of x is equal to negative times the square root of x minus 2. Well, first, let's look at the -2 under the radical sign. Well, why did I go first, like inside the radical sign? Why am I looking at the radical first? Well, because when you're doing order of operations, you follow PEMDAS, right? Or GEMDAS. So in other words, you look at what's inside the parentheses or what's inside the radical sign. So this is actually pretty much negative of the square root of x minus 2. So there's a grouping symbol inside. So I'm going to interpret first what's inside. So I'll be consistent with the order of operations. Okay, so how do I describe the transformation? So for the -2, that means it's a horizontal translation. But since it's horizontal, we do the opposite, right? We don't follow the sign. So this will become 2 units to the right. Now for the other constant, which was -1, and that was multiplied to the function. So since it's multiplied to the whole function, then that's going to be reflection in the x-axis. There you go. For the second one, you have square root of x and then -6. So that's outside the radical sign. So if it's outside, it's a vertical transformation, right? So it's a vertical translation. If it's vertical, we follow the sign. So since it's -6, we go 6 down. Okay. Next, number 3, you have a -3 multiplied. So two things are happening here. When you multiply it by 3, since it's vertical, you follow the sign or you follow the value of the constant being multiplied. So that means this is a vertical stretch by a factor of 3. And since we're multiplying the function by negative sign, so this will be reflection in the x-axis. Okay. Last but not the least, you have a constant multiplied inside the radical sign. So the fraction 1/4 is part of the radicand. So that means that's a horizontal effect. So since it's a horizontal transformation, you have to either reverse the effect, right, or go to the opposite direction. So since this is being multiplied, instead of shrinking it, we say it's a horizontal stretch. by a factor of, so now you reverse the effect, you do the reciprocal. So the reciprocal of 1 over 4 is 4. So those are just some examples on how to interpret, transformations of square root functions.